Well, folks, let's do some prime factorization. Well, I think one of the key words here is the number prime. So what we really need to do is figure out what numbers are prime, and we already have figured that out. So I'm going to grab a list of numbers, and we're going to use this list right here that you can see. So this is a list of prime numbers, and it is clearly not an all-inclusive list. The number of prime numbers is, okay, here we go. In a previous lesson I asked, I wonder if this list goes on forever, and the answer is yes. There is an infinite number of prime numbers, and they're continually finding bigger and bigger ones. The biggest one they found is bigger than I can explain. I forgot how big it is, but I think it's like millions of digits long. It's crazy. Okay, so I'm going to make a list of these prime numbers over here on the side. So 2 is a prime number, and I'm doing this just because later on I'm going to need this list. So prime, 2 is prime, 3 is prime, 5 is prime. I'm circling them for reasons that will become obvious later. 11, 13, 17, 19, 23, 29, 31, 37. There are more. I've run out of board space. I think that's going to be sufficient for now. So the only numbers we're going to factor are going to have these factors to them. So here's what we're going to do. We're going to start factoring some numbers, and when I factor a number, I need to make sure that whatever I'm dividing into it divides without a remainder. So let's just start with a basic example, and we're going to start with the number 12. Okay, so I need to think of two numbers that multiply to give me 12. All right, automatically off the top of your head, you're like 2 times 6 or 4 times 3. I hear you, you're right, you're not wrong, you're jumping right at it, and that's great. What I'm going to do, and I'm not trying to slow you down, but what I'm going to do is look on my chart, because sometimes I'm going to get ridiculous numbers that are really hard to see. So like if I said, hey, what multiplies to give me 102? It may not be very obvious, right? Here's my multiplication table, and yours might be handwritten, but I'm looking for 12, and I see 12, and it's 3 times 4. I also see it as 2 times 6. So either one is good. You don't have to use the multiplication table. But if you do, it might help you identify things that you had not seen earlier, particularly when the numbers aren't things like, well, 12. Okay, so two numbers multiply to give me 12. You could do 3 times 4, or you could do 2 times 6, either one. I'm going to do 2 times 6. If I see a prime number down here, I'm going to circle it, and I'm done. Okay, so 2 is prime, see, because it's prime, it's circled. So I circle it, and I'm done with that number. Now let's come over here to 6, and I think, okay, two numbers multiply to give me 6. So I could do 1 times 6, or I could do 2 times 3. Let's not do 1 times 6. Let's do 2 times 3. And both of those are prime. So we're done. We just factored the number 12. Well, let's go a little bit further. When we're done, we know we're done when we have circles at the bottom. Everything is a prime number. I've come all the way down and I've circled it. And I've circled everything at the bottom. And I have prime number, prime number, prime number. And so I have truly factored this into its prime numbers. Okay, factors are things that are multiplied together. And so 2 times 2 times 3 would give me 12. Let me show it to you. So if I did 2 times 2 times 3, then I'd get 12, because 2 times 2 is 4, right? So I'd have 4, and then I'd multiply by 3, and 4 times 3 is 12. So yeah, sure enough, it works. Now, I could have started this problem with 3 times 4, or 4 times 3. I would have the same answer in the end. So I'm going to go one more step, and I'm going to say, well, 2 times 2, I have 2 2's. So it's 2 squared times 3. And I have just factored 12 into its prime factors. So whenever you have work on this, I recommend this process, but you need to rewrite it like that. Okay, let's do another one that's going to be a little different. Let's use the same color. We'll use blue. We'll just kind of divide this up right here. This one's going to be a little bit different. Let's do 16. Okay, I need two numbers that multiply to give me 16. We have a couple options. You could do this off the top of your head. You could say 4 times 4, and you're right. You could say 2 times 8, and you're right. You could say 1 times 16, and that would get you nowhere. And let me show you why. Don't write this, okay? You're good so far, but don't write what I'm about to write. If you do 1 times 16, well, first of all, 1 is not on my list of prime numbers. 1 is neither prime nor composite, which is the opposite of prime. And now you have a 16. Well, you needed to do that one anyway, so now we do it again, and we could just see, and this goes all day. We ain't got time for that. So whenever you're trying to think of what multiplies to give you a number, don't do 1 times the number. Which is another reason that when you reach a prime number, you're done. Because you could say, well, 2 is 1 times 2. Well, why would you write it again? Okay, let's start this over. And let's think of 2 numbers that multiply to give me 16. We've already done it. I've already said them. But when the numbers get bigger, you may need to look on your multiplication chart. So just for practice now, I could say, well, 16 is here. It's 4 times 4. Oh, I see a 16. It's 8 times 2. You could say, oh, I see a 16. It's 16 times 1. Don't use that one. Okay, so either one is good. You could do 4 and 4. You could do 2 and 8. I want to do 2 and 8. Whenever you have factored and you've split things off into a tree, when you reach a prime number, you circle it. When you reach a non-prime number, you stare at it and you go, wait a minute, I can factor 8. And it factors into, well, you can look on your multiplication table, but you probably know it. It's 2 times 4. Oh, 2 is prime. But 4 is 2 times 2. Okay? And again, 2 is prime. So I look at this and I'm done, and I know I'm done because I've circled everything. There's nothing else hanging at the bottom that needs to be factored. So I'm going to write it as, you can skip this step if you like, but I'm going to write it as 2 times 2 times 2 times 2. This is why we have exponents, because nobody wants to write 2 times 2 times 2 times 2. Instead, we look at it and we say, you know what, I have 1, 2, 3, 4 of them, so I have 2 to the 4th power, which makes sense. 2 times 2 is 4, times 2 is 8, times 2 is 16, and it works. Okay, we're going to go through a few more examples, and they're going to get a little bit crazy. So I'm going to leave that example up, and I'll bring an example over here. So here goes. Let's do 100 and 104. Whoa, okay, all of a sudden things got weird. You know how I said, what multiplies to give you whatever? And you'd be like, oh, I got this. Oh, now when I say what multiplies to give you whatever, I don't have this. Like, I don't know what multiplies to give me 104. I really don't know. And so we have a couple options here. We could look on our multiplication chart, and I'm going to actually. And I see it. It's kind of hard to find. It's a little bit obscure, but it's there. So there it is, 104. So 13 times 8. I mean, you could do that if you wanted to. If that didn't pop in your head to try that, then we can try lots of other things. And in a minute, I'm going to show you what that is. But right now, I'm going to go with 13 times 8. So, see, some of them are a little bit tricky. So 13 times 8. If you have factored and you see a prime number, circle it. 13 is prime. How do you know? Because it's on my list. That's why we made that list. Is 8 prime? No, it's not. Actually, everything that I have here, I'm about to put it here. Because 8 is 2 prime times 4. 4 is 2 prime times 2 prime. And we're done. It was that easy. Okay, so if you were lost at the first step of 13 times 8, I got it from looking at the multiplication chart. The multiplication chart we did in class didn't go this large. So we didn't ever reach 13 times 8, okay? We stopped at 10 times 10, so it's not that big. But you'll see it on different multiplication tables. So nevertheless, it's there. And I'll show you another method. But let's start writing things. Let's do the small ones first. Let's not start with 13. 2 is smaller. I'm looking at my circled numbers. I have 2 times 2 times 2, there's 3 of them, times 13. Okay, well that's great, but nobody wants to write that, and you don't even have to write this step, because you really have 1, 2, 3 of them. So I have 2 to the 3rd times 13. I do want to show you, 2 to the 3rd is not 2 times 3, it's 2 times 2 times 2. It means you have 3 2s. All right. Let me go a different route, and let's do 104 differently. And if you don't want to copy this one, that's cool, that's fine. But I'm going to do the same number here, but I'm going to tackle it a slightly different way. And I'm going to tackle it by trying to divide some of these numbers into it. So I'm going to grab a calculator. And if you don't have a calculator, don't panic, because you have a phone. And you also have a device that has Desmos on it. Desmos is a great online calculator, and you can type things in, and it'll do all kinds of great stuff. So here's the deal. I'm going to type 104, and I'm going to divide something out of it. So I'm taking a guess. All right, what do I want to divide? Do I want to divide 2, 3, 5, 7, 11, or whatever? Well, I know 13 goes into it. I'm going to start with 2, though. Okay, so 104 divided by 2. And when I press enter, I get 52. If I would have divided something and gotten a decimal, I can't use it. Okay, for example, since I did 104, I divided it by 2, I got 52. That's great. If either one of these numbers would have been decimals, I can't do it. And I'll show you what I mean. But before I go any further, let's do that, okay? For example, if I would have said, oh, well, what's 104 divided by 3? It's a decimal. Anybody got time for that? Let's not write that, okay? So now what I need to do is find 52. What multiplies to give me 52? We have a multiplication chart. We can look on it. That's great. I'm actually going to come back over here and I'm going to try 2 again. I'm going to be like, well, maybe 2 goes into 52. All right, so let's try that. I'm going to do 52 divided by 2. And if I get something that is not a decimal, then I'm going to use it. 26. Fantastic. I'll put this calculator in my nerd pocket. All I need is a pocket protector now. So we just said 52 divided by 2, which is prime, by the way. And we got 26, which is not prime. It's not on my list. So I'm going to divide again. What do you want to divide? I don't know. 2 seems to be working pretty well for me. I'm going to try 2 again. And I'm going to try 2 until it doesn't work. Okay, so I'm going to stick with 2. So here goes. Please don't rely on a calculator for all these. I'm just showing it as a demonstration. 26 divided by 2 is 13. Okay, so what that just told me was 26 is 2 times 13, which is prime. And notice 2 times 2 times 2 times 13. It's in a different order, but that's okay. It's the same thing. So final answer, same thing. 2 to the third, that's a 3, times 13. That's it. All right, I'm going to do 1 or 2 more, and they're going to be tricky. Actually, I don't even know what I'm about to use. I'm gonna pick one that'll just make you sweat. It'll make you so angry you're just gonna get mad. So here we go. Let's do this. 7, 3, 1, 5. Oh my goodness. This one's gonna be a mess. Okay, here we go. Let's start it. First of all, you will not see that one on your multiplication table. It's just not going to happen. I'm sorry, but it's not. It's too big. So we need to start experimenting and asking ourselves, okay, what divides into this? So let's go through this logically. Let's think very logically through this. If 2 goes into a number, then we would say that number is even, meaning it ends with a 0 or a 2 or a 4 or a 6 or an 8. Okay? So like 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. Those numbers are even. This number is not even. So I can try to divide a 2 into it, and it's not going to work. Just because it's necessary to go through this process, let me show you. So here we go. I'm a calculator, and I'm going to do 7315, and I'm going to try to divide 2 from it. See that 2 right up there? I'm pointing at it on the board. I'm going to divide by 2, and if I get a decimal, then I'm not going to use it. Oh man, see that 0.5? Can't use it. Dang it. Okay, so 2 is not an option for this, which tells me at the end, when I get to the very end of this, a 2 is not going to be in my answer. So I'm not going to have a 2 at all. Let's try 3. I'm going to go ahead and tell you 3 does not work, and here's how I know. I'm going to go through this quickly. If you add these digits together, you have 7 plus 3 is 10, plus 1 is 11, plus 5 is 16. 3 does not go into 16. If you add the digits together and 3 goes into that, then 3 goes into this. But that doesn't happen. If nothing I just said made sense, that's okay. There's no shame in that. Let's do it. You could try this by hand, or just for the sake of time, I'm going to do this. And we have a decimal. See that decimal right there? We don't need it. So 3 is not an option. However, I will tell you, because it ends in a 5, or if it ends in a 0, you know it's divisible by 5. So we're going to do that one. I'm looking for my marker, but it was in my pocket. That's embarrassing, isn't it? We're going to go ahead and say, well, you know what? 2 things multiply to give me this. Unless it's prime. This one's not prime, of course. I wouldn't be that cruel. 7315 divided by 5. There we go. Oh, there it is. 1463. So this is 5 times 1463. Now, this could be prime, but it's not. I'll go ahead and tell you this one's not. Numbers that are prime, they can be this big, obviously. As I said earlier, the largest prime number ever found is like millions of digits long. It's ridiculous. Nevertheless, this is not prime. If I made this list forever, this would not be on that list. So the thing is, I wonder what else goes into that. And everything on this list will go into this. There are bigger primes, but we're going to stop here at 37 for now. So I want to know what goes into that. Well, let me waste your time for just a moment and show you what you don't need to do. If I did 1463 divided by 2, it would be a waste of time. I already know 2 doesn't go. So when I've divided it out and I've made it smaller, 2 still doesn't go. 3 still doesn't go. 1463 divided by 5 maybe? I'm going to say it's a no, and I know that because 1463 doesn't end in a 0 or a 5, but still, I got a decimal. So 5's not an option. Okay, 2 doesn't go, 3 doesn't go, 5 went divided into it without a decimal, but we're done with 5 and we need to move on now, so let's go to 7. Maybe 7 works. 1463 divided by 7. Do I get a decimal? No, I got 209. Oh, fantastic. Let me grab this marker out of my pocket. So 7, which is prime, of course, and it went in there 209 times. Well, I wonder what else happens. Let's keep going. All right, 2's not an option. 3's not an option. We've used 5, can't use it again. We've run out of the ability to divide 5 out of this. We tried 7. Let's try it. Maybe 7 divides out of it again. So we're going to try 7 again. 209 divided by 7, and oh man, it's a decimal. So we can't use that. So we can't use 7, but we can try 11. Maybe 11 goes into 209. 209 divided by 11, 19. Oh, how beautiful. So 11, which is prime, times 19. Which is prime. Yes! This is great. There we go. All right, let's write the final answer. And this will be the final answer. 5 to the 1. 7, there's one of those. 11, one of those. And 19, one of those. So 5 times 7 times 11 times 19. We are done with that. Let's do one more. Just one more. A good problem for some amazing practice. Trying to think of a really good one. Got it. 900. I'm not going to use a calculator on this one. It's not necessary. There are times you may want to grab a calculator to test things. You can do things on paper. That's cool. But I'm not going to use a calculator on this. If I gave you $900, lucky you, if I gave you $900, then, well, I shouldn't be handing out $900 like that. But if I did, I would try to give it to you in $100 bills. I would give you 9 $100 bills. Okay, 9 is not prime, not on my list. 100 is not prime, even if my list kept going, it's not on there. All right, so let's factor 9. I need 2 numbers that multiply to give me 9. Wonder what they are. Well, let's see, 9 is 1 times 9, which gets me nowhere. It's also 3 times 3. Oh, 3 is prime. And, well, then this one must be prime also. Okay, let's do 100. 100, all right, if I was going to give you just $100, I could give you a $100 bill. I could give you 100 ones. I could give you 5 20s. I could give you 10 10s. I could give you 2 50s. There's a lot of things we could do. So there are multiple ways we could do this. Don't write what I'm about to put. You could put 2 50s. You could put 10 10s. You could put 5 20s. And you can turn these numbers around. You could say, I want to have 20 here and 5 here. There's lots of things you can do. So I'm just going to pick one. And for the sake of where this is going, I'm going to pick 10 and 10. And 10 is not prime because 10 is 2 times 5. Well, 2 is prime, 5 is prime. Okay, so we're good there. And then 10 is, oh my goodness, I just did this problem. I did it right here. So let's do it again. 2 times 5. Okay, got that one. Great. So let's write the final answer. And I'm going to go ahead and jump straight to the final answer instead of being like 3 times 3 times 2 times 5 times 2 times 5. I don't want to write all that. We don't have time. Final answer. I'm going to go from smallest to biggest. The smallest circled number, the smallest prime number is 2. 2. How many of them do I have? I have 2 of them. 2 squared times. Next, 3. 3 times 3. Oh, 3 squared. The next one, 5. I have 2 of those. There we go. 2 squared times 3 squared times 5 squared is 900. This is a perfect square. Let me show you what I mean. I want to show you a couple things, and then we're done with this lesson. Sad, it's been so much fun. 900 belongs on this diagonal because what you see down here, you see all these even exponents because they're all even. This is going to be a perfect square. That didn't make sense, it's okay, don't panic. But really, I could have started this by saying 30 times 30. So if that diagonal on the multiplication chart would have continued, we'd have a 900 in there. Okay, that was the first thing. Second thing, I'm going to check my answer. I just want to make sure I'm right, because if I'm wrong, I might cry. Of course, I'll turn off the camera before I do that. And I'm going to try my answer. I'm going to do 2 squared times 3 squared times 5 squared. And when I do, I get 900. So if you want to check your answer when you're done, you can. Like I want to check this one right here that I'm pointing to. 5 times 7 times 11 times 19. 7315. Yes, it works. There we go. And that's how we factor into prime factors.